Good evening, everyone, and welcome to Straight Science. Straight Science is an evening seminar series put on by University of Alaska Fairbanks Northwest Campus here in Nome and University of Alaska Fairbanks Alaska Sea Grant, also in Nome. And tonight you're in the work office. So there really needs to be no introduction for Rick Thoman. Rick Thoman started his career in Nome in the 70s and went on into the world, leaving Nome a little bit behind for a couple of decades while he slayed the dragons of National Weather Service in Fairbanks, and has now become the UAF climate specialist for the Alaska Center for Climate Assessment and Policy at the University of Alaska Fairbanks. And one of the best things we've got in the region is Rick Thoman working for us out here, always giving us information, always giving us the news of weather and climate and starting that conversation, bringing us all together. With that, Rick is going to give us a review of what happened this winter and where we may be headed. Maybe we can talk about that sun picture also afterwards. With that, take it away, Rick Thoman. As always, the Bering Strait region is so glad you're with us tonight.
All right. Thanks very much, Gay, and thanks everyone for joining in. So, let's see. Last Straight Science I did, kind of with a weather and climate review, was in October, late October. And so this is going to kind of pick up from there. So basically what happened this winter, what happened this spring, and by request, what may happen this summer. So let's go ahead and jump right in. So that is my plan here for this evening. Obviously, it was an extremely active and in many ways unusual winter, not just for Nome, but for much of Alaska, and plenty to talk about. Spring was very interesting as well, and summer here is starting out with some pretty interesting stuff going on as well. There is really never a dull moment, is there, in our weather and climate. Okay, so let's start out. Here are some highlights. These are kind of the climate scale highlights. Overall, we started off in November, a really low snow November. Some, but pretty low, but little enough snow that with an extremely mild and rain in December, we pretty much lost that snowpack. So really quite remarkable. The snow did return in early January, but temperatures remain pretty mild for the rest of that midwinter season. So overall, the December through February average temperature at Nome was the 5th highest in Nome's 118-year climate history. Has been warmer, but this was in the top 5%. Part of that was driven by a real lack of cold days. During the midwinter season, only 15 days had low temperatures of 0 or lower. That's the least since the winter of 2001. And only 3 days the entire cold season got to 20 below or lower. So, and again, the least in almost a decade there. Now, as we'll see here, November and December were pretty low precipitation months. January, though, made up for it to some extent. We had more than twice the normal precipitation, wound up being the 5th highest for January, and most of that was snow. Otherwise, it could have really been a bust of a year. Now, as we'll see, big pattern change in March brought us some of the coolest weather in the middle of March since 1995, nowhere near record levels, but unusually cold compared to the last few decades. One of the most interesting things was, and you may disagree, but the data doesn't lie. Well, it can lie, right? The average wind speed in March at Nome Airport was only just 5.7 miles an hour, less than 6 miles an hour. That is the lowest average wind speed for any month since actually March 2017. When we look at the entire spring season, very, very different from midwinter. Average temperature was almost exactly normal, and precipitation was below normal, especially compared to recent years. Most years since 2017 have had excessively high precipitation during the spring season, but not this year. So one of the things that I've started doing, and I actually really like this because, you know, more and more it's clear that if we don't keep track of what's happening in the region, it's going to get lost to history. You know, some of this is my interest is the loss of the data from the Weather Service. So, you know, all the snow data, even the precipitation data has become more reliable. So I really like this idea of basically keeping some kind of a diary like this, and find a way to preserve this in perpetuity here. We got our recording of this, I guess that will help. Of course, the Nugget does a great job at that too. So here's the start of the 2024-25 winter season diary. So first sea ice there about the 19th. By about 10 days, 9 or 10 days later, we had higher sea ice concentrations right near shore in Nome. Then as December rolls around, we really get into that really warm pattern. So December 9th, 10th, 11th, the temperature remained continuously above freezing in Nome for all 3 of those days. That's the most consecutive days in Nome in December, with staying above freezing day and night. And we had 2 school closure days due to rain during that time, as well as the ice from the snow and from the melting of what little snow there was and the rain, and capped off by the December 11th, 44 degrees. It's the highest temperature ever recorded in December in Nome's 118-year climate record. It was the first monthly record high temperature set since June of 2013. Now, right around winter solstice, an event, the sea ice drifted away except for a few hundred yards of shore ice that I think was interesting at the time, but later proved perhaps important as we went through the winter and we saw a very unstable ice near Nome. After the really warm weather in December, early December, second week there, then we went into this completely dry pattern. So we had wiped out nearly all of the snow. There wasn't much. Then it warmed up and rained, and then it was completely dry. And so the new year starts in low elevation Nome, you know, with just very, very patchy snow cover. That finally changed the first week there in January, but we had more rain early February, not like the snow melting rain of earlier. A non-weather thing there on the February 2nd, of course, but very notable for the region, that 4.7 magnitude earthquake in the Bering Strait southwest of Wales. Very, very notable. And then folks noted some out-of-season bird sightings there, also the first week in February. So next slide is the later part of the diary here. Again, partly weather related, of course, the Bering Air crash out on the ice on the Bering Sea on the 6th. And that tragedy, you know, that occurred during some very warm weather, with undoubtedly where icing was a contributor to that. Really the very unusual event, February 11th, when we saw that nearshore ice break off and the Nome forest floated away. You know, we just have not, I have looked if anyone knows anything like that in the past. At that point, we had the ice break off in March of 2019, but not in the first half of February. That is really remarkable. Um, uh, Another one from Gay, we had that bowhead whale sighting near Sledge Island at the end of February. And then weather pattern changes, and Jesse Holmes wins Iditarod 53. Was the coldest, or at least the lowest temperature for a winter in more than 15 years. Not super cold, but and it was calm, so a nice under the stars. And was there any aurora out then? At any rate, a pretty nice Seward Peninsula weather for the winter of Iditarod this year. The ice never really recovered very much from that February 11th breakout. By late April, we were down to just low concentration ice drifting by. Unlike some years recently, we had a nice and sunny and warm Memorial Day, but then spring ends on the 30th. Brisk winds and chilly, and there was even a bit of snow around town. So really quite a I think an eventful diary here shows up. All right, let's get to the hard sciencey part. So here are Unalakleet and Nome temperatures, November through May. The bars are the daily departure from average, and then the numbers are just the monthly departure. So just run your eyeballs across the top, Unalakleet, bottom, Nome, and obviously the first, November through February there's a lot of red bars, so indicating days that were warmer than normal. Even once the pattern changed, we did have some cold days and strings of cold days there in March, but March started warm in both Unalakleet and Nome and ended warm as well. So the departures from normal were not super large. Big change from the midwinter, but not super large. Similarly, as we went through the spring months there and ended up with May, where temperatures were above normal. So really quite interesting there, I think. Here is how the season worked out. This is from our climate reanalysis model, and I've zoomed in there to Western Alaska. So the average temperature, departure from normal, is in each graphic. The winter is on your left. The spring is on your right. So winter, nothing but red on there. There is no place in this area covered that was below normal, and only kind of the western portion of Chukotka, or the eastern, let's see, that'd be the eastern portion of Chukotka was even in the near normal. Really warm, not just across western Alaska, but everywhere there. That darkest red color would be temperatures 8 degrees or more Fahrenheit above normal for the 3-month average. That is really impressive. On the right-hand side, very different graphic. It's actually the same temperature scale as on the right. So it's an apples to apples comparison there. And you can see very different pattern, generally below normal across the northern Seward Peninsula down through the Bering Strait and St. Lawrence Island. Small area there in eastern Norton Sound where it was a little bit above normal, but no place has those big extremes like we saw in midwinter. That we would expect, but this was really quite dynamic. The other thing I want to point out in the spring, of course, in the spring is the time of year when, on average, climatologically, the Bering Strait and St. Lawrence Island are significantly colder than eastern Norton Sound. This year, that we had that standard pattern, but kind of on steroids, so that temperature difference between Unalakleet, Shaktoolik, Koyuk, and Gamble, Savunga, Diomede, Wales was enhanced over what it normally is, and normally it's pretty large. So we really had strong temperature differences across the region in the springtime. I do want to bring this up. I think this is a good documentation of the temperatures that we saw on the warmest December day, at least at Nome, in the last 118 years. And this is basically every single report that was available. You'll notice there are a few missing there. The FAA stations at Wales, Shishmaref, and St. Michael were not operative on these days, so I had nothing to plot there. But 46 degrees at Banner Creek, 46 at White Mountain, 46 at Shaktoolik, really remarkable for just 10 days shy of the winter solstice. So Nome set an all-time December record, and that 39 at Kotzebue is also an all-time record for the month. Now, I mentioned about the springtime, that temperature difference, and I just wanted to highlight this. This is the same kind of graphic that we were just looking at, except this is just for March. And look at the dramatic difference in normal. So this isn't just the raw temperature, which is almost always, right, colder in the Bering Strait and St. Lawrence Island than Eastern Norton Sound in the spring. And it was really amplified in March. So that's temperatures there, 5 degrees or more below normal through the Bering Strait and St. Lawrence Island, and as much as 2 degrees above normal there on the Eastern Norton Sound coast. So really very dramatic. Notice Nome is near the edge of that, kind of near the dividing line for the above normal versus below normal, and that even more so in the spring. So I did say that I would do some comparison here with, okay, how did the winter and spring compare for Western Alaska versus the Arctic? And so here's the comparisons. The Pan-Arctic view. Winter is on the left, spring is on the right. This is just the 3-month average temperature. And the stripes there show areas that had a top 3. Warmest, I don't think there's anywhere that had a top 3 coldest in the Arctic for winter or spring. So in the winter, you can see that Western Alaska really was part of a warm Arctic that was found almost everywhere. North of 60 degrees latitude, the only areas showing up in this climate analysis that were even a little bit below normal were on the Greenland ice sheet there. But most of the Arctic was warm, and in fact, for the Arctic overall, it was the warmest midwinter since the data set here that I use since 1950. Very different story for spring. First of all, wasn't the warmest spring. It was the 5th warmest, so still pretty high ranked. But especially through the Bering Strait and St. Lawrence Island, a little bit below normal, and you can see there was not much of the Arctic that was with any amount below normal. The cold in Greenland was replaced by significant warmth, and there's a little bit of below normal there around Svalbard, but overall near to significantly above normal dominated the Arctic. And so basically the Bering Strait region and Chukotka were the primary areas in the Arctic that were any amount cooler than normal for the spring. All right, let's turn to precipitation. If you've been with us before on these reviews, I like to do this kind of graphic. So what this shows is the cumulative precipitation, in this case, since November 1st at the Nome Airport. The shading indicates whether the cumulative precipitation to that point is above or below normal. And the bars show the days when it was especially windy, when the average daily wind speed was 20 miles an hour or higher. So in this presentation, you can see that we were running below normal precipitation from November right into January, but then January made up that entire deficit. Now, the other thing that strikes me out of this is that we kind of have what looks to my eyeball here like kind of a typical number of windy days, being defined as average speed of 20 miles an hour or higher, up until early February. And then it's not that I forgot to plot anything. There were no days after the second week in February where the airport had an average wind speed of 20 miles an hour or higher. And that is pretty unusual for Nome to kind of have the end of the winter high wind season so early. The other thing I want to point out here, as we know, we lost the snowpack there in mid-December due to the warmth and the rain, and then there was no precipitation at all. So effectively, we started building the winter snowpack on January 7th, and we did a good job of making up for the deficit, but we got up to normal, but that was about it. And the last of the adding to the snowpack snow was in mid-April. So we only really had a little over really 3 months of building snowpack from the second week of January to the third week of April. And there was not really much after middle of February. There was a little bit of snow there in early first half of March, but after that it was just smaller amounts. So really, by Seward Peninsula standards, a pretty short snow accumulation season this year. Oh, and you can see by the time we get to the end of April, the total precipitation for, at least for Nome Airport, almost precisely normal. So here's the numbers part of that. This great picture from Gay on January 3rd there, looking up the Cougar Rock Road. So this year, November, December, only 42% of precipitation. Going back in time, 2019 kind of had similar low precipitation and thin snowpack, but not this dramatically thin. 2012 was also another November, December with very low precipitation, but the distribution was very different. There was hardly any precipitation at all in November. I think there was 200s or something like that, just barely over zero. And in fact, we were still getting snowfall measurements from the Weather Service in 2012, and we're only carrying a trace of snow on the ground until the second week in December. Then the snow came. It didn't snow a lot, but it was cold, and we went past New Year's with a decent snow cover. So in recent years, we haven't seen quite anything like this with such low snow cover. So going past New Year's. If you go back farther, of course, you can find some years like this. Particularly 1969 was an incredibly dry winter, and that lasted all winter. So here's the mid-April snowpack comparison from our climate analysis model. So this is not relative to normal. This is just relative to last year. So we're comparing April 15th this year to April 15th last year. And you'll notice all across Western Alaska, according to the climate analysis model, significantly less snow, water in the snowpack. So the snowpack much less, all up and down Western Alaska, from Bristol Bay all the way up to Northwest Arctic Borough. In fact, for most of the state, near or less snow than we had the year before. A couple areas there in the interior and in the Kenai Mountains were a little different. But for Western Alaska, really, that short snow season, I think, really shows up in where we were at the end of the season. Also, last spring was significantly colder than we were this year. So that's contributing to this as well. All right, so let's turn to sea ice. All right, so now we're back to the early part of the season. The green line is the fall and early winter of 2024-25. The blue line the previous year. The thick black line is the 2006 to 23 smooth median there. And so this is using that the man-machine mix, that the multi-sensor sea ice analysis. And I like to use this early in the season because it does not have the problems that the passive microwave satellite sensed ice has near shore. So the green line there, you can see, except when we were at very, very low ice coverage there in November, part of November and early December. Overall, we were running well behind both the previous winter and the longer term median there to kick off the ice season. Here's the sea ice radar grab that I made of that breakout right around winter solstice. On the left-hand side is the Saturday at about 3 o'clock ice image there, and you can see there's plenty of ice off along and offshore of Nome. But 24 hours later, the north winds had kicked up and really move that ice away. There's still a few hundred yards there of shore-fast ice that remained, but a lot of either open water or just low concentration bits of ice floating around. Again, I think pretty, yeah, it's kind of really interesting to see this at the time, but given what then happened in February, we had relatively late arrival of ice. It really took to the last days of November until we had a good ice coverage at Nome, and it never really was able to set up. Time and again, it got pushed away, and we just weren't able to develop that nice, thick, shore-fast ice. And here is the breakout. I really want to thank everyone that shared photographs of this. This is a great one from Ben Townsend at KNOM. On the 12th, the ice moved late on the 11th, and a beautiful day for photographs here. Really fantastic. This is a drone picture, and really gives a good sense of just what happened here with the ice. And this is really fantastic documentation of this ice breakout in the first half of February. Just amazing. Here's a couple more wonderful photos from Gay and Janet. If you look hard here on Gay's picture on the left-hand side, Gay, those are eiders swimming around there, aren't they?
Yes, they're a little bit to the right of center. One,
These
two,
guys
three.
right in here. Really. So February 12th, eiders swimming around on the ocean in Nome, and a beautiful sunset picture there from Janet. Really fantastic imagery and a great documentation of this very unusual event. Here's what the Bering Sea ice extent looked like for the whole season. Now here we're using our passive microwave data from the National Snow and Ice Data Center. This is one of the ice products that is threatened due to funding cuts here. This is the product that goes back more than 45 years now with daily sea ice measurements, and we really don't want to lose this. You can see here the blue line again is this year. The green line is the previous winter. The thin lines are every single season, 1978 to now, and the thick black line is just, again, that smooth, in this case, 30-year median. The blue line there, you can see for most of the season was running well below that thick black line, well below the median, and also most of the time below the previous year. So this is sea ice extent on the entire Bering Sea, both the Alaska and the Russian side. If you look hard, though, cast your eye to the right-hand side there. You'll see that after a relatively late peak in the sea ice extent, March 26, which was the latest occurrence of the maximum sea ice extent in the Bering Sea in 10 years, it started to go down in April, but then it rebounded, and we almost were back up to the maximum. It didn't quite make it, but we were almost back up to the maximum there the third week of April. Really unexpected, from at least for me, to see the ice return. Now, having said that, the maximum sea ice extent in the Bering Sea was very low this year, effectively tied for the fourth lowest in the 47-year satellite record. One of the reasons I don't want to lose this data set. I want to be able to make comparisons like that. But then you can see after that third week in April surge, the ice decreased, even maybe even a little faster than is seasonally expected. And so overall, below normal sea ice extent, but definitely less so the middle of April onward. So here is from the National Weather Service. This is just a 4-panel with some snapshots of the ice. So starting on the left-hand side, so there we are at November 27th. We've got ice in Norton Sound, ice just in the day or two previous to this, now pretty solidly into Nome, still wide open through the Bering Strait down to St. Lawrence Island. February 13th, so that's right about the time of the ice breakout in Nome, and this was about at the minimum of that dip in the significant dip there in the total sea ice extent. You can see here we are just about Valentine's Day, and we've got basically very little ice south of the Yukon Delta and St. Lawrence Island. There's a little bit there on the north shore of Kuskokwim Bay, but practically nothing in Bristol Bay. Notice the areas there, if you look hard there, eastern Norton Sound on February 13th, there's open water being analyzed by the National Weather Service, as well as some lower concentration ice there off of the northern Seward Peninsula coast as well from those east to southeast winds. So the next one over is March 26th. So this was the day of the maximum Bering Sea wide ice extent. You can see it's quite advanced from February 13th. We do have ice now well south of Nunivak and somewhat south of St. Matthew there, well south of Cape Navarin on the Russian side. Still very little ice in Bristol Bay, and the ice is well north, though, still of the Pribilofs. Now, May 3rd is when, things are getting really weird here in the later spring. So May 3rd, there is a lot of blue there, a lot of basically less than 1/10 open water there in Norton Sound, in a large chunk of the Bering Sea there north between St. Matt and St. Lawrence Island. A lot of open water there in the Gulf of Anadyr as well. But look at that higher concentration ice to the south, and we've even got that thumb of ice extending all the way to St. Paul. So this year, did ice get to St. Paul? Yes, but it took until early May to get any kind of substantial ice to St. Paul. Didn't last very long. It was only there for a few days. But, ice around St. Paul in early May historically would not be unusual, but not the first arrival of ice in early May. That is for sure. So really, especially later spring was just, I've called it weird. And, the more I look at it, it is weird. Okay, so how about some explanation for that, Rick? Okay, so here is our prevailing near-surface wind direction. So not wind speed, but just the direction here. The big ball there is, of course, Nome. So on the left is our midwinter season. What I want to point out here is the prevailing wind direction in this analysis shows up as east, not northeast, just basically east. What that is indicative of across the northern Bering Sea in the winter is often indicative of frequent shifts between north and south winds. So you add those together, and you wind up with this east wind prevailing. Compare that to the March and April average on your right-hand side, and now you see north winds dominating all across the Seward Peninsula through the Bering Strait and all the way south past the Pribilofs to the Alaska Peninsula. Why did we have such a goofy ice by the time we got to early May? this is why we had this change in the weather pattern that kept the ice at bay pretty far north during the midwinter, but then the change to north winds was able to push that relatively thin ice but higher concentration ice south, and so we have increasing open waters in the north, but this remnant ice basically being pushed south by these very persistent north winds. So really quite an unusual pattern here that we see for the split between the midwinter and then the spring. And here's how it looks up at the mid levels of the atmosphere. Of course, meteorologists really like to look at this level. So we're about halfway up in the atmosphere, about 18,000 feet above the ground. About half of the mass of the atmosphere is above you and half is below. 18,000 feet is not very high, right? You're at 18,000 feet in the Nome to Anchorage Alaska Airlines flight, and that means you're on approach into Anchorage, right? So the atmosphere is a pretty thin cover across our Earth. But wind direction matters a lot at this level. On the right-hand side, I'm sorry, on the left-hand side is again the midwinter, December through February, the pressure pattern, if you will, and the arrows show the direction from which the wind is blowing. So for the 3-month average, we've got low pressure anchored over the far southwest Bering Sea, and farther east, we've got, for the 3-month average, all these south winds at the mid levels of the atmosphere. The colors here are, you can think of this as the pressure departure from average. So we've got comparatively high pressure blowing out of the south. That's a recipe for a warm winter across western Alaska. Very, very different for the March through May spring season. Low pressure centered almost exactly over the Bering Strait. And so we have lower pressure, very relatively light winds for the 3-month average. This is a setup in the spring for a cold pattern, and that's exactly what we got from the Bering Strait westward. Because we're on the east side of that low, it's a little more nuanced Nome eastward there. And so as a result, we wound up without big departures like we had in the wintertime, but with that Bering Strait as kind of the edge of the warm versus cold. So that's where we've been, and hopefully some explanation of why we were there, and now the outlook portion of the program. All right, so let's start off with our 50-year trends for the midsummer, 1975 through 2024. So this is the total change in the temperatures on the left and the total precipitation on the right. Nome is the big black dot there. Western Alaska, like all of Alaska, like everywhere on this graphic here, from Western Canada all the way to Chukotka, is warming. The maximum warmth there, or the total change over Norton Sound and Kotzebue Sound, that is, of course, reflecting both the earlier loss of sea ice and the influx of warm continental water in the big rivers that drain into those bays. But you can see that it's warming everywhere. The least warming for Western Alaska there through the Bering Strait and St. Lawrence Island, with a much more maritime climate. It is warming, but not nearly to the amount that it is on the mainland. Now, probably going to come as exactly zero surprise to anyone on this call that Western Alaska, for the most part, is getting wetter in the midsummer there. And the Seward Peninsula region is basically at the center of that wetting. That's not found statewide, but over the last 50 years, total precipitation has increased between 10 and 50%. So that, remember, that's the change in the average precipitation over that 50 years. So definitely things are getting wetter, at least over the last 50 years, for the 3 summer months put together in Western Alaska. All right, so that's our long-term trend. Now let's go to our model outlook. So we're going to start off looking at the ocean here. So on the left-hand side is a forecast for the sea surface temperature departure from normal. This is from the European Climate Change Service. This is from a bunch of different models, put them all together, and what we're showing here is the average. Alaska's at the top here. Unfortunately, this graphic is not easy to rotate there, so you just have to kind of turn your head a little bit. You can see where Nome is there. The interesting thing here is that for the Chukchi Sea and down through the Bering Strait, on the Alaska side of the Bering Sea, you can see either near or even a little bit below normal for the 3-month average. Different story, basically, from Chukotka southwest, so the western part of the Bering Sea. The forecast is for sea surface temperatures to average above normal, but not the case in the waters near Alaska. And that, of course, for the summer season, when we are have increasing concerns about harmful algal blooms, this is an interesting outlook. On the right-hand side is the brand new, just came out 2 days ago. Sea ice outlook. Climate Prediction Center is still able to produce this experimental sea ice outlook. So what I have plotted here, one of my favorite products out of this. So what's the date of the first open water? And it's relative to when this forecast was made. So this was actually from data from late May. So while many of those areas there that are shown in the red have had open water previously, since this model is forecasting that they will have their first open water basically now, and that's working out pretty well. What I want to stress here, you'll notice going up the Chukchi coast, actually we're in that later July color there for Utqiagvik, Point Barrow area, and even into August along some portions of the Alaska Beaufort Sea coast. That in and of itself is not terribly unusual. However, if you've been on our monthly climate outlook calls, you may remember that is later than this model had been forecasting the first open water, which even last month, almost everywhere on the Beaufort Sea coast, first open water was forecast in July. So so the model appears to be picking up on our higher ice conditions that we have at this point relative to what the model might have thought there would be last month or especially the month before. All right, now the Climate Prediction Center outlooks. And I wanted to show this because I actually have no memory of this dramatic a change. It's been pretty chilly start to June across much of the state. In Southeast, it's been rainy as it has been since April. In cool parts of South Central, yesterday had one of the coolest June days of record, at least as far as high temperatures go. Gay was mentioning that snow squalls in the Bering Strait today. By itself, not that unusual for the beginning of June. What I wanted to stress here was how dramatically this forecast from the Climate Prediction Center has changed. So on the top is the June forecast that was issued on May 15th. And you can see that the forecast for Alaska, basically southeast and the southern part of the state, eastern interior, were tilted to favor significantly above normal. All of western Alaska was in that equal chances. So that doesn't mean near normal, means no reason to tilt to favor above or below. Look at the change in the forecast that was issued for June on May 30th. The entire state tilting to favor significantly below normal. That is a very, very dramatic change. I have no memory of that kind of change in a forecast from CPC. And why did they make that kind of forecast change? Between May 15th and May 30th, the models really latched on to really forecasting a quite cold June across most of the state. So it was a big model switch. And of course, by May 30th, it was apparent that at least we were going to start off June on that cool side. Precipitation outlook didn't change very much, and not at all for Western Alaska, which again, equal chances, so neither above or below normal favored, but really quite the dramatic change in this outlook. Now, the month-by-month forecast, this again from the Climate Change Service, from the Europeans. And again, Alaska's at the top there. And you can see for Western Alaska, maybe we're in the white space there for June. So that's on the left-hand side. So that's, that's the neither above or below normal favored. That kind of holds into July, although we're getting closer to tilting above normal. And by the time we get to August, all of mainland Alaska and St. Lawrence Island, there are favored in the significantly above normal as the most likely category. So what I get out of this is a forecast made in early May, so does not have the most recent information in it. At that point, we basically, I think we're seeing the effects there of those cooler ocean temperatures persisting through the first part of the summer, but that's weakening by the time we get to August. Here's the precipitation outlook for summer, again from the Climate Change Service. Not much to see there in June on the left-hand side, but July in the middle, much larger area, at least modestly favoring above normal rainfall. For Western Alaska, that kind of fades away in August. It continues across the interior to favor significantly above normal. But based on this, for Western Alaska, the most favored month for above normal rain would be July, which is probably not what folks would really like to hear. And finally, the CPC outlook here. Again, this is not updated at the end of the month, so this is the May 15th version. And for the 3 months summer, you can see, except for portions of the Northwest Arctic and North Slope there, above normal favored, strongly, by forecast standards, a strong tilt there for Southeast. For warmth, precipitation, most of mainland Alaska was favored for significantly above normal precipitation. No tilt for the Alaska Peninsula, Aleutians, or Southeast. So that's what I have for you tonight. I want to say Koyanak for having me, Gay, and I really want to call out everyone that's contributed, however you do, to helping us keep abreast of what's happening in our environment in these times of rapid change and chaos in the monitoring abilities. And we can only do it together. That's really the only way. No one's coming to save us. We have to do it. So that's it.
All right. Well, thank you, Rick Thoman. I kind of my whole screen went dead, so I just crawled back on, but I had you on the phone. So we'll see how the recording works. But thank you so much, and I was listening, and what a great presentation. So for the Straight Science audience, while you're thinking of your question, that's right. DJ Reed, he's got it. This is the time to show Rick Thoman some love in the chat box. It is never easy to be a public speaker, and we are so grateful that Rick, who's had as long a day as anybody, doing about 10 times more because of all the cuts and people having to not be at their jobs and things like that. It's really falling on fewer and fewer people to do more and more. And he took time at the end of a long day to reach out to the Bering Strait region and give us all that great information. So thank you, Rick Thoman. I know you're always appreciative of us, but we're darn appreciative of you. So while that's going on, I see Charlie, you have your hand up. Go for it. Glad you're on.
Okay, thanks. Yeah, Rick, I really enjoy your talks, and Yeah,
Thanks, Charlie.
I think you're a resource. I wanted to reminisce I believe it was 1983, and the ice went out in Nome almost to the beach, and it was early March, I believe. I remember the day because I'd spent the entire day putting a number of crab pots for research in, and the wind started to come up about 5 o'clock, and I got off the ice, and within a half an hour, it all blew away. Um,
Early March 1983.
I believe so, and
Got it. Thank you.
and it was there was heavy pack ice, and the cake of ice that my pots were on was migrating west, kind of rolling almost down the coast. And so the next day we were able to get out on that pan and retrieve most of our gear, but it was there was just a thin band along the beach. I believe it was before I did a rod, and I'm pretty sure it was 1983.
All right, excellent. I appreciate that.
Okay. Yeah. Well, thank you. Yep. Thank you.
All right. Any other, lots of kudos in the chat box for you, Rick, but any other questions? I know I've got a couple. Let me check here in the chat. There's so much. All right. Well, oh, Larry Hinsman, I see you have your hand up. Go ahead. Glad you're on board.
Yeah, thanks, Gay. Thanks, Rick. Always interesting. I'm curious. I'm really concerned about, the AOC, Arctic Ocean Observing System, said funds cut. And I'm worried about the National Weather Service getting cuts in observations. I think I heard you talk a couple of weeks ago about loss of the measurements of the balloon measurements and the measurements of the winds aloft. I'm curious, what kind of feedback are you getting from across the state, from the people of Alaska and from our local political leaders with respect to the need for observations in Alaska?
Well, that's a tough one, Larry. You know, part of the problem that we have in Alaska is that, of course, not all of this is new. In particular, the problems we've had with aviation observations and getting those, it's been going on for years. And I think everybody recognizes that we need those aviation observations, which of course not only support aviation, but they support public safety. They support weather forecasting. They support weather models. It's been a little bit tougher with things like the weather balloons. But I think many people do understand that while that's not at the same level of immediate impact, say that the loss of an airport observation is, in the long run, it's going to have a big effect. And I hope that we've seen some response from the Weather Service with the plans that, I know 6 weeks ago, the plans were to, reduce or eliminate the observations at 4 more sites in Alaska, and those plans have been modified, and so we're not going to lose as many of those now. I hope that's in response to the understanding that this kind of information is important.
All
Does that work,
right.
Larry?
He's shaking his head yes.
Yep. Yeah. Thanks, Rick. Appreciate that. And that's actually some good news there. So thanks for that.
Wonderful. All right. That's nice to have good news. Ebet, thanks for being patient. You've got your hand up. Floor is yours.
Thanks, Gay, and thanks, Rick, as always. We were just curious listening with my son here in Juneau. Early in the talk, you mentioned the Nome forest floating away, and we were curious what that was.
I will pass that to a Nome resident to explain what that is.
Charlie, you better be the explainer, because you'll get it right for Gnome Forest, if you're there.
Yeah, I'm back. So I'm the guy that's been putting it out recently, and uh, it's sort of a joke, and we have a good time with it. But we collect everybody's Christmas tree in January, and then we go plant those relatively close to shore, and we have some plywood cutouts with people, figurines, and animals. Some fanciful, some not, and it's just a funny thing we do. It started out to pick on tourists on at the Iditarod, but since then, a lot of residents in Nome enjoy it too. And we actually have a golf tournament and amongst the trees and other things. So it's just a silly thing we do in Nome.
And it was quite sad. A lot of people were sorry to see it go. So Ebed, it's all the old trees just put on the ice, and some fun things. You can go down there and walk around, take pictures, and and some of the cutouts, Charlie, were quite historical. They were 30, 40 years old by people who are no longer here to redo those signs. So
yes, that's true. And I've got a bunch of plywood, and haven't got around to making more figures, but it's on my list. So.
And typically the trees are and the cutouts are planted 100, 150 yards offshore. Does that sound right?
That sounds right. Yes.
And in the chat, Charlie, don't go too far away from your microphone. Larry Hinsman is asking, is that Charlie Lean? Yes, that is Charlie Lean.
Yes.
The Charlie Lean.
Crazy Charlie. Yeah.
All right. Well, my question is, since I don't see any others, is so down here we measured the water temperature at Cape Nome on May 30th, and it seemed awfully warm to me. It was 5.7 C, or 42 degrees, basically. So that was a bit of I guess I shouldn't be surprised since the ice has been out and so weak for so long in front of town, but gee whiz, when you look at the Chukchi, where we had that sort of the ice just sort of shattered and melted in place, and your explanation was great about the winds, but the Chukchi seems to be packed pretty tight still, given that we're adrift. And you can see that, like in the story today of the pilot coming back, and it was just like, winter up there. Is that unusual to have so different right next to each other? We've got this warming water. I'm surprised we haven't had a lot of fog. Sorry, Gnome. I hope I didn't just curse us, but such a warm water. And then the Chukchi doesn't seem to be, it's like a pretty good line right there, just north of Diomede. Any thoughts on that? Is that a weird setup?
It is really really a different situation with where we're at the moment. As on May 31st, so the last day of May, we had the least amount of open water in the Chukchi Sea since 1999.
Holy moly.
On the other hand, the Bering Sea ice was basically the remnant ice between St. Matt and St. Lawrence Island, and a little bit hanging on in the far western Gulf of Anadyr near shore. You get just north of Diomede, and it is basically a wall. What open water there has been a fairly persistent lead off of the western North Slope coast. Things are starting to change now. We are getting some ice breaking now beyond the fast ice off of the northern Seward Peninsula coast. There's increasing meltwater and channels being cut in the ice in Kotzebue Sound, but it really is night and day. And just based on, again, that sea ice index, one of those threatened products, it has been, we haven't seen this like this in the 21st century. So very interesting situation.
Wow, thank you. It just looked weird, so thank you for confirming that. Dean Stockwell, your hand is raised. It's your turn. Go ahead. Dean Stockwell, you are muted and your hand is raised. You've got the floor. While we wait, oh, is he back? Oh, he must have dropped his hand or jumped off, one or the other. That's all right. My other thought was, with that low snow year, we've sort of been in this region, you hear a lot of sort of, people might call it gloomy and doomy, right? We're hearing these things, we're seeing things that some of it really is gloomy and doomy. But one silver lining that we're noticing of having the low snow, that very, very low snow year, is that the animals, some of the ungulates like moose and muskox, come into the town. For those of you outside of Nome, they come towards the town when they're calving and are wanting to eat the freshest new sprouts, because Nome, I think because of our patchy permafrost, or maybe because of the mining, our sprouts come up kind of early, our forage for them. So they come in, and I have to say, we don't, from just data-free opinion, we've seen moose very heavily pregnant coming in a few weeks ago, and they're still hanging around and have had calves, and they came in looking fat. So it's been very nice to see the good body condition of the land animals. I'm not sure what's happening yet. We'll hear more as the maritime harvest continues in the region and on into the Chukchi and up into the Beaufort. But for the land animals, it's been, like I say, data-free opinion, but it sounds like from everyone around that I've talked to, it's nice to see fat moose. So there was low snow, lots of ability to forage, lots of ability to run from predators. It looks like that may have been a silver lining for us, given the warmth and the rain and the low snow. So just
Good to
adding that.
hear.
Yeah. And the last statement I was going to say was, we don't have, and I think you just can't get satellite imagery in before like mid-February because of the angle of the pass and the low light. Is that right?
The imagery we can get is much more restricted. Yeah, that's correct.
Yeah. So it was interesting to see what was, we were watching that ice break off here in February. We had the rain in February. We had terrible things happen in February, but when I saw those birds, mallards and eiders, there was eiders in that photo, within 24 hours of the ice breaking off, those birds were seen. And I was thinking, boy, I haven't seen a good image of where the ice is. You get those sort of cartoon drawings from the National Weather Service Sea Ice Program, but what's it really looking like? And to see those birds, that was around, I don't know, the 11th or 12th. And then you showed up with the first ice image that sort of gave us on the 13th, that overhead photograph of what was happening. And that ice was right up against the edge of the ice, was sort of, I would say, less than 100 miles south of St. Lawrence Island. And so it was nice. It was just nice to see that what the local observations were proven by the satellites. So it was just a nice mix of people's observations, knowledge, that we're talking, everybody was talking what you're seeing and so forth, and then having it confirmed that the ice edge was so close to us on the 13th. So it is stunning what happened in March, and that's how to save the day. And the question now is, was March, which was lovely to have that cold and clear air, was March enough to make enough ice to form a good thermal separation? So as now we're going into the summer or ice-free season, is it enough? Did we get enough cold to hold back the southern Bering Sea ecosystem from rolling on into the northern Bering Sea? And we've seen that happen in 2017, 2018, and this may be We just don't know, but we're seeing that warm temperature off Cape Nome. There's not a lot to go on. I'm sure there'll be sea surface temperature data, hopefully sometime soon, but know that we are wondering what lies ahead, kind of a thing for our summer. So it's interesting that Chukchi's so cold. Dean Stockwell, you're back, and take it away.
Can you hear me?
Yes, sir.
Okay, so we've talked about this being one of the warmest springs in quite a while. And we also talked about this is one of the lowest open water areas for the Chukchi. But the western Bering is already showing water temperatures of 5 degrees and a couple blooms taking place along that coastline. And on the eastern side, we're seeing water temperatures of 5 to 7 degrees. So I just want to put out a suggestion is not to relax for the observation of HABs coming up there, because they still can bloom in water temperatures approaching 8 degrees or so. So just be cautious.
Yeah,
Thank
good
you,
work,
Dean.
Dean. Thanks.
Again, thank you for the talk, Rick. Really appreciate it.
Is there any other information, Rick, that we can, since we're all on here and interested and you've been so kind, is there anything you're specifically looking for that we might see, any of us in Nome and region might see and be able to pass along one way or the other, that you would be of especially of a special interest to you?
If everybody just keeps doing what they're doing, sharing things you see,
Yeah.
and that, by putting that all together, keep our running environmental diary going. I think that, that's the kind of thing that's gonna get more valuable with each passing year. Having that record of what we're seeing, and what you are seeing with your own eyeballs, documenting that is going to be really, really important for the future.
Well, we thank you for always making sense of it and giving it back to us where we're like, oh, that actually makes sense. And this is what it meant. So thank you so much again. Any other last questions for Rick, who's had a long day? Seeing none, we'll say thank you, Rick. If you want to stay on for 1 second afterwards, that would be great. And we're not going to have Straight Science next week, but on the 16th, we're going to have Kowarik and the Marine Exchange and Corey Erickson give us a presentation on Arctic Watch, which is a program they're working on to promote safety, improve safety at sea in the Bering Strait region with large vessels. So with that, we'll see you next time, not next week, next time on the 16th. Thank you all so much for coming. Have a good night, everyone.